Hello, geometry, and here we go with lesson 4. So name the 4 shortcuts to proving triangles congruent. We've done 4 of these in the last 2 lessons. The first 2 were SSS and SAS, and then the last 2 were ASA and AAS. We are learning the 5th one today. The 5th one is a little different, I will tell you that. It's called HL theorem. Now, what it says is if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one leg of another right triangle, then the triangles are congruent. Now, the HL theorem only works with right triangles. So if I'm trying to prove 2 triangles are congruent and they're not right triangles, I've only got 4 shortcuts to use, the 4 that I said at the beginning of the notes. If we have right angles, though, you have a 5th option. The other 4 are still available, but you have a 5th option. Okay, so 3 things need to be true to use HL theorem. 1, we've already gone over this, but just to say it again, you need right triangles. Okay, you need the hypotenuses congruent. And you need one pair of legs congruent. You don't need both, you just need one. All right. The picture shows what you need. Now, if you look at that, I talked about how angle side side, which is what that is not good, right? Spells a bad word. The only time it works is when it's a right angle. If the angle's a right angle, then that becomes HL. Okay. Again, only in right triangles. Okay. All right. So what additional piece of information is needed in each set of triangles to prove them congruent, specifically by the HL theorem? All right. So we want the HL theorem to be used here. I know that there are several ways you could prove these triangles are congruent using the other shortcuts, but I want to focus right now on the HL theorem. So if you look at part A, you've got the hypotenuse is congruent and you've got a leg congruent. You don't know that you have a right triangle. So we would need to know that angle T and angle Q are not equal. If they're equal, it doesn't tell me anything, but we have to know that they are right angles. If they're equal, and that's all we know, then that's ASS, and that's bad. It's not, they wouldn't prove anything. But if they're right angles, now we have HL theorem. Okay. B, we do have right angles on this one. What other thing do we need? Do we have? Well, we have RY is congruent to itself. So those are actually the hypotenuses of those triangles. We need one leg, one set of legs. So we could have either TR congruent to EY, or TY equal to or congruent to ER. All right. You don't need both. You just need one, and then you would have HL theorem. Okay. Using algebra, what values for x and y would make the triangles congruent by the HL theorem? Well, they would be congruent if that was congruent to that, and the hypotenuses were congruent as well. So let's write some equations. X equals y plus 1 and 3y equals x plus 3. This is substitution, right? I have x by itself, so I'm going to take the y plus 1 and put it in for there. And so I'm going to get 3y equals, instead of x there, I'm going to put y plus 1 plus 3. So that's y plus 4 Subtract the y, I get 2y equals 4, and I get y equals 2. Now I can plug that in and get x. So let's do that down here. X equals 2 plus 1, which is 3. You can check it just to make sure, plug those in, and those should make congruent sides. All right, proof practice. So yeah, this difficulty level is a 5. I want you to focus on the layout of the proof, okay? Those symbols right there, the upside down T's, those mean perpendicular. Now, that was given to us. Both of those things were given to us. And then notice what I'm saying. JLM and LJK are right angles. Okay. Why are they right angles? Well, that's the definition of perpendicular. I told you that those two lines are perpendicular. And so I'm using the definition of perpendicular lines to conclude that JL and LM, so JL and LM meet at a right angle. Okay, that's what that's concluding. So this is a right angle, and this is a right angle. All right. Now, technically, what you want to say here is that JLM, triangle JLM, and triangle JLK are right triangles. But I'm going to just tell you to be safer here, I'm not going to worry about the distinction too much. I'm going to say that these two things are equal. Angle JLM is congruent to angle LJK. Why are they congruent? Well, all right angles are congruent. Okay, well then MJ is congruent to KL. How do I know that MJ is congruent to KL? It's given. So that's 2, right? The first one was step 3. That was the first congruent piece. Step 2 was the fourth step. And then the reflexive property says that LJ is congruent to JL. Right, look, the order is changed in the statement up here. I know that's what we're trying to prove, but you can use that to kind of help you a little bit. There's your third piece. Now I can say that those two triangles are congruent because of HL theorem. All right, and that's a proof for you. Got 2 more to do. So I'm going to type again. Statement 1, you can do a couple different things. You got 3 pieces of given information. I'm going to start with the right angles because that's what this is all about. So angle A and angle C are right angles. I'm just going to abbreviate to angles. How do I know that they're right angles? Well, it's given. Well, what does that mean? Well, that means angle A is congruent to angle C. Why? All right angles are congruent. Again, I will talk more about that in class. Technically, what you should say here is that triangle ABE and triangle CBD are right triangles. But we're going to just stick with this for right now. All right, so all right angles are congruent. There's one piece. I'll go with the next easy part. EB is congruent to DB. It's given. And that's our second piece. B is the midpoint. I'm not just making that up. It's the midpoint of AC. That was given to me in the words. What does that mean? Well, if B is the midpoint, it cuts something in half, right? B is the midpoint of AC, so those got cut in half. So I can say AB is congruent to CB. I use the definition of midpoint to say that. And that's my third piece. Now I can say the triangles are congruent. So triangle ABE is congruent to triangle CBD. Why? That would be HL theorem. Right? Got right angles. The hypotenuses are the EB and the DB, and then one leg. That's HL theorem. Okay. One more. By the way, that one difficulty level is a 3-4. If you do it the technical right way, which again I'll talk about in class, it's a little more difficult, but yeah, it's about a 3 or 4. Same with the next one. Okay. So here we go. Step 1. I'm going to start with the right angles again. Angle M and angle N are right angles. Let's give it. Okay. Angle M is congruent to angle N. Why? All right angles are congruent. We'll go ahead and mark that that's my first. Okay. What else did I give you? I gave you that other angle down there at the bottom, angle, and I can't say angle L, doesn't make any sense. MLO is congruent to angle NLO. That was given. Mark it. All right. Fourth step. I need a side. I've got 2 angles right now. Need a side. Which side is it? Well, hopefully you see that it's LO is congruent to LO. Why? Should know that one by now. It's a reflexive property. But again, mark it. That's the third piece. So now I should be able to say that the triangles are congruent. This is where it gets a little tricky. What's the reasoning? A lot of people are going to put HL theorem here. It's not. It's angle side. What I want you to notice here is right angles do not guarantee that you'll use HL theorem. So I'll write that out here. Right angles do not guarantee you will use the HL theorem. Okay. Make sure you catch that. Right angles do not guarantee that you'll use the HL theorem. You can use the HL theorem, but it's not 100% every time. Right angles on this one, and we used angle side. All right. So that's all the shortcuts. And we will add one more thing with the next lesson.